Let's take a look at homework number 5, question 9. This is another one of the word problems. I think that as we work through a few more of those and think about how we should think about word problems, these are going to start getting easier for you. So they are saying that the demand function for the luminar desk lamp is given by the following function, where X is the quantity demanded in thousands and P is the unit price in dollars. Okay, so they said that P here, P, whatever we would come up with if we solve this equation, that is the price, and that's a price in dollars. Okay? So X is the quantity demanded in thousands. So anywhere we see an X, that's how many lamps people are ordering. So how many lamps? Basically, X tells us the number of lamps, P tells us the price in dollars. So now we know what the function is. Let's figure out what they want from us. So it looks like for part A, they're asking for f prime of X. Well, we don't even have to think about lamps, we don't have to think about prices, we just need to think about our differentiation rules. And the rule that we're going to use here is going to be the product rule. So if we look at our original function, f prime of X is going to be when we take the exponent and we bring it down. So we're going to have to multiply this 2 times negative 0.1. That's going to give us negative 0.2x, and we subtract 1 from the exponent, and that's just going to be x to the first. This one here, we've got an x, and we know that when we use our power rule here, we're just going to get the 0.2. Our x is going to go away because it's going to the 0th power. And then our constant rule, the 28, well, that's going to disappear too. That's going to turn into a 0. So our actual derivative here for A is negative 0.2x minus 0.2. What does that tell us? Let's think about that for a second, because this one here gave us price in dollars, and the derivative gives us, well, we know that that's the rate of change. So this is going to be the change in price, the rate of change, actually, the rate of change in price. So if we have a question later on that asks us for the rate of change, we're going to use the derivative. If we have a question later on that asks us for the actual price, well, then we'll use the original function. And what does B ask us for? B asks us for the rate of change of the unit price when the quantity demanded is 12,000 units. They said in the problem that units are in thousands, so that actually means we need to be looking at f prime of 12. So they wanted 12,000, but we know this is in 12 units of 12, so, or units of 1,000, so that's going to give us a 12. So we need f prime of 12. Well, that's going to be negative 0.2 times 12 minus 0.2. If you are comfortable doing this kind of math in your head, you're more than welcome to, but I would encourage you, just to avoid mistakes, to maybe pull out your handy-dandy gigantic calculator and see if you can use that to help you solve these without having too much trouble. So I need a negative 0.2, and I'm multiplying that times 12, and then I'm subtracting 0.2, and my handy-dandy calculator, you can't read the screen, it says the answer there is negative 2.6. Okay? So yeah, either do it in your head, plug it into your calculator, but here it says basically when they have a demand of 12,000 lamps, that their rate of change in their unit price, it's going to go down $2.6 per 1,000 lamps. So that is the answer for part B. You're just going to take your derivative that you found here, plug in the 12 for the 12,000 lamps, and solve it. Now, you might not have a 12. They might give you a 15. They might give you a 20. But you're just going to plug whatever they give you. And it actually says right there in the question, x equals blank in the parentheses. It'll tell you exactly what to plug in for x for part B. So plug that into your derivative and then solve. And then finally, they ask us, what is the unit price at that level of demand? Okay, so we need the unit price when the level of demand is x equals 12. When people want, when there's a demand for 12,000 lamps, what's the unit price? Well, our derivative gave us the rate of change, but our original function is the one that gives us the price. So what we're going to do is plug that 12 into our original function. So this is going to be f of 12. And that's going to equal, I'll bring it down here a little bit so that I have enough room, that's going to be negative 0.1 times 12 squared minus 0.2 times 12, and that's plus 28. So all I did was took my original function and plugged the 12 in everywhere I saw an x. And once again, I'm going to make use of my handy dandy calculator here. Let's see. So I have negative 0.1 times 12 squared. That's 12 times 12 minus 0.2 times 12 plus 28, and I hit enter, and it tells me that the unit price at that level of demand, if we plug in 12, is going to be 11.20. So that's the cost of a lamp at that level of demand, and you're just going to plug in the 11.20 for your answer to the second part. Oh, I guess that isn't C. That's the second part of B. And that should do it. If you still have questions, if something doesn't make sense, shoot me an email, and I will get back to you and try to clear things up for you.